Hello, class. In this video, I'd like to go through the solutions for Lab 3.8. This is where we experiment with the change of base formula. So the first problem we have is log base 6 of 39. See, our calculator is in base 10, right? So anytime there's a log with nothing written underneath it, we assume that it's base 10. So unfortunately, our calculator cannot just simply type log base 6 of 39. So we have to change this to base 10. So here's the formula. Log base b of x is equal to log base 10 of x divided by log base 10 of b. Right? So we've changed this to base 10. So a lot of times the students, the mistake I might see would be they would write log 6 over log 39. But just think about this. It looks like the 6 is on the bottom. So put the log base 10 of 6 on the bottom, and the 39 looks like it's above the 6, so make sure your 39 is above the 6. And in your calculator, you're going to enter log 39. Let's just do that very quickly. Log 39 divided by log 6, and press enter, and there's our answer. Okay? So there's not much to that. If you look at problems 2 through 6, we're using properties of logs to rewrite the original expression. So here we have log base 10 of 1.3 to the x. So we can rewrite this by simply taking the exponent and putting it in front of the expression. So the x goes in front of the log base 10 of 1.3. And that's it. There's nothing more to do here. Question 3. All right, so we have the natural log. 2.5 raised to the x, so you bring the x in the front, and that's all we can do here. X times the natural log of 2.5. Number 4, you have to be careful to keep that exponent in parentheses. So the exponent is x plus 6. So take the entire exponent and put it in the front, but make sure you keep the parentheses because this log base 10 of 4 has to be distributed to the x and the 6. Okay? If we look at number 5, we have natural log. Again, we'll keep the exponent in parentheses. The exponent is 5x plus 4. Place the exponent in front. And here's a little identity here. Look, we have natural log of e. And if you look up top, natural log of e is actually equal to 1. So we really have 5x plus 4 times 1, right? Because this is equal to 1. So 5x plus 4 times 1 is just 5x plus 4. And then the last one, we take the 6x and we place it in front of the expression. All right, 6x is my exponent, so I have 6x times log base 10 of 10. And again, log base 10 of 10 is equal to 1. So this is really 6x times 1, okay, because we were given this up top here. Log base 10 of 10 is equal to 1. Okay, number 7, it says, okay, use your knowledge of powers to estimate powers of 3 to estimate the solution that 3 to the x equals 19. So if I try 3 squared, well, that's 9. That's too small. I need a bigger value for x to get me closer to 19. If I place a 3 into x, I have 3 cubed, which is 27. That's too big. So I know the value of x that's going to give me 19 is somewhere between 2 and 3. So we can say x is between 2 and 3. Now we can check this same problem algebraically, right? So we know our answer is x is somewhere between 2 and 3. Let's get the exact answer. All right, so if we take the log of both sides of the equal sign, right? So log of 3x equals log 19. We can rewrite the left side of our expression using properties of logs. Remember, if I have a log base 10 of 3 to the x, I could take the x and put it in front, just like we did with problems 2 through 6. We took the exponent and put it in front. The exponent we placed in front. That's really what we're doing for this question number 8. We're taking the exponent in front of the log. So you have x times log base 10 of 3 equals log base 10 of 19. And to get x by itself, divide both sides by log base 10 of 3. So this is going to cancel. And you're left with x equals, and I'll do it on my calculator, right? X is going to be equal to log of this 19 divided by log 3. And we have 2.68 is our answer, or 2.6801. right, to go 4 decimal places. And then the last thing we can do, we can actually graph this if we wanted to. Take a look. If I were to graph, press y equals, and on the left side I enter 3 raised to the x, and then I graph the right side of my equation, which is 19, right? So I'm graphing both sides of the equation. 3 to the x is my y1, 19 is my y2. Let's take a window. Actually, I just need some number bigger than 19, so maybe 30 would work. I press graph. That is 3 to the x, the blue line. And then I have a straight line at 19. There it is. And then to calculate the intersection, we press second. Above trace says calc for calculate. We want number 5, the intersection. Press enter 3 times. And the intersection happens at 2.68. Look at that. 2.6801, 2.6801. So I actually just solved this 3 ways. I estimated the solution, right? We found out that the answer is going to be between 2 and 3, and 2.68 is certainly between 2 and 3. We used logs to solve this using algebra. And then we graphed both sides of the equation, and we still ended up with the same answer. Thank you for watching. I'll scroll back just so you can see the solutions one more time. Have a nice day, guys.